Hello, my name is Oliver Waddington, and in this video we will be discussing the networking fundamentals of two network protocol models. These fundamentals include the operations, features and services of the two models in question, which are the OSI model and the TCP IP model. Let's get started with the OSI model. So what is the OSI model? The OSI model stands for the Open Systems Interconnection Model, and according to Wikipedia, it is a conceptual and logical layout that defines network communication and provides a reference model for how applications can communicate over a network. I would say that the key words from that description are conceptual and reference model. In other words, the OSI model is nothing more than a guide that can help explain how a network operates and can also be used as a troubleshooting guide to ascertain where a specific problem has occurred within a network. The model is broken down into layers, each of which represents a conceptual collection of services provided to the layers above and below it. Above and below means that the OSI model acknowledges both the sending and receiving of data. So what are these 7 layers? Layer 7 is the application layer. This is the layer that the user directly interacts with. The most common example of this layer would be a web browser. Although this is the most common example you would use, it also includes other end-user functions such as mail applications, file transfer applications, and programs designed for remotely accessing a device, as well as many others. Layer 6 is the presentation layer. The presentation layer is used to present data to the application layer in an accurate and well-defined and standardized format. According to Wikipedia, data can be communicated in different formats via different sources. The presentation layer is responsible for integrating all formats into a standard format for efficient and effective communication. So what does all this jargon really mean? Here we have an example of a relatively standard website. As you can see, it's made up entirely of code. Modern websites are typically made up of HTML code, which provides the structure and main content of the website, CSS, which handles the visual and styling elements, and JavaScript, which can be used to manipulate objects of the website to make them perform specific functions. Now, even if you know about developing websites, unless you've got skills like Neo from the Matrix and can visually see websites in code format, this is just a long list of text. It's during the presentation layer, however, where all this code turns into this. It's important for all the code to be exactly right and as it should be, or it's likely that the website won't function as it should. This is also the layer where data encryption and decryption takes place, as well as any compression function that the information might need during transfer. Layer 5 is the session layer. The session layer deals with creating and maintaining a session between two devices. So for example, if you were trying to access a website, at the session layer, your computer would create a session with the web server that is hosting the website you're trying to access. Wikipedia describes a user session as the period of time a user interfaces with an application. The user session begins when the user accesses the application and ends when the user quits the application. Layer 4 is the transport layer. The transport layer is responsible for delivery of information from one device to another. This layer dictates how the data is sent. These protocols are categorized as TCP and UDP. TCP is considered a reliable connection, while UDP is considered unreliable. The term unreliable, however, doesn't connote a bad or poor connection, as the word may imply. With this concept in mind, which protocol is used to transfer the data sufficiently is dependent on the type of data that is being sent. TCP is suited for applications that require high reliability and where transmission time is relatively less critical. So for example, as mentioned in layer 6, the code of a website has to be perfectly placed or you run the risk of the website not displaying or functioning correctly. So the transfer layer would use a TCP connection to deliver a website so as to ensure that every part of the code was delivered correctly. UDP, on the other hand, is suitable for applications that need fast and efficient transmission. UDP is faster to deliver than TCP as there is no error checking. Using a VoIP service such as Skype as an example, if something was to happen to the connection which prevented a segment of the audio and/or video from being transferred, this would only affect the data that wasn't sent. So with a UDP connection, there is no guarantee that all the data would make it to its destination, hence the term unreliable. But a UDP connection also means that the transfer and delivery of data will continue and amend itself despite certain segments being missing. At layer 4, the datagram is known as a segment. A datagram is essentially a unit of transfer that is associated with networking. It's at this point where a little independent knowledge on network components is beneficial. According to the Office of National Statistics, 22 million households in England had internet access in 2014, which is approximately 84% of households. We can assume that the majority of these homes will use the network devices that were provided by their internet service provider. These devices are often mistakenly referred to as routers, such as this one provided to PlusNet customers. These are in fact multiple devices merged into one easy-to-use device. Their main independent components are a router, which allows the connection of one network to another. So for example, it allows a home-based network to connect to the internet. A switch, which allows a connection from one computer on a network to another computer on the same network, as well as allowing those computers to connect to the internet. And a wireless access point, which allows a connection from a device to a network without the need for any cables. This is commonly used for devices such as phones and tablets. The network layer is the point at which the router operates. This is where one network connects to another. An easy way to remember this is to think of it as the networks layer as opposed to the network layer. In the previous two layers, we have been discussing the connection and transportation between two devices. But how does one computer on any given network know to send information to a very specific device on a completely different network? Well, every device on a network is provided with an IP address. This is known as a private IP. On home networks, these are typically assigned automatically by the router using a DHCP protocol. Using a combination of your private IP as well as your public IP address that is provided by your internet service provider, it's possible to create a theoretical map of where data is being sent and from where it is being received. Put simply, an IP addressing system is very much like the addressing system that the Postal Service use. In the same way they deliver mail and packages to and from addresses, so does the third layer of the OSI model. This is known as logical addressing. This logical addressing will also be used to try and find the quickest path to get the data to the requested destination. At this point, the datagram is referred to as a packet. The term packet is more commonly used as a broader term for a general unit of data that is made into a packet. Whilst this is the correct term for a packet, it is often used where the technical unit doesn't apply in the OSI model and alternatives should be used. One of the main differentiations between Layer 2 and Layer 3 is that where Layer 3 provides connections to other networks, Layer 2 provides connections between end users on the same network. So this is the switch element of our ISP provided network devices. The data link layer is divided into two sublayers, the media access control layer and the logical link control layer. The MAC sublayer controls how a computer on the network gains access to the data and permission to transmit it. The LLC layer controls frame synchronization, flow control and error checking. Where the previous layer uses IP addresses, this layer uses MAC addresses. MAC addresses are an individual address found on every end user device capable of connecting to a network. As these are assigned to the physical device, this is known as physical addressing. The data that is being transferred knows the physical addresses of the two devices that the data is travelling between. At layer 2, the datagram is called a frame. Layer 1 is the physical layer. And this is the culmination of the physical and non-physical elements that make the transferring of data between devices possible. For example, these can include the cabling that is physically used to connect the devices, as well as the network card that is embedded into the device, as well as many others. By this point in the OSI model, the data is transformed into bits. The physical layer also deals with the bit-level transmission between different devices, which are commonly sent as a series of electrical signals in the form of ones and zeros, until all the information arrives at the appropriate destination. This, however, is only half of the OSI model. As previously mentioned at the start, the OSI model provides a model for sending and receiving data. So let's imagine user 1 has sent an email to user 2. It starts at the user's chosen email client. It is then compressed and encrypted and continues being changed to different datagrams until it arrives at the physical layer, where it is sent as a series of electrical signals to user 2's physical layer, at which point it is returned to the necessary datagram to allow to continue up the OSI model until it is finally presented in its intended form at the application layer. Next of our two models is the TCP IP model, and once again we must ask, what is the TCP IP model? It stands for Transmission Control Protocol and Internet Protocol, and it is a language a computer uses to access the internet. It consists of a suite of protocols designed to establish a network of networks to provide a host with access to the internet. TCP/IP is responsible for full-fledged data connectivity and transmitting the data end-to-end by providing other functions including addressing, mapping and acknowledgement. The main difference between this description of the TCP/IP model and the previous description of the OSI model is that there is no mention of it being either conceptual or a reference model. For want of a better word, the TCP/IP model is real. It is actually performing the functions being discussed as opposed to just discussing them. First, we need to differentiate what the TCP and IP aspects actually mean, both of which we have already discussed in the OSI segment of this presentation. The Transmission Control Protocol layer handles the data. The data is broken down into smaller units called packets, which are then transmitted over the network. The packets are received by the corresponding TCP layer at the receiver and reassembled into the original message. The IP layer is primarily concerned with the transmission portion. This is done by means of a unique IP address assigned to each and every active recipient on the network. This is all sounding somewhat familiar to the OSI model. However, the TCP/IP model only has 4 main layers for us to discuss. Layer 4 is the application layer. The application layer is concerned mainly with human interaction and the implementation of software application and related protocols. Using these applications and application protocols, data can be moved between hosts and remote users can communicate. These protocols include HTTP, SMTP, DHCP, DNS, SNMP, FTP, and the TFTP. As you may have noticed, these protocols coincide with layers 7 to 5 on the OSI model. Layer 3 is the transport layer. The protocols in this transport layer are the same as the transport layer found in the OSI model. Out of fear of repeating myself too often, I will simply remind you using the 2 previous animations that provide an example of the difference between TCP and UDP. The main functions of the internet layer are transmitting data to and from the network interface layer, routing data to the correct destination network and the correct device on said network. It also handles packet errors and fragmentation. This is linked closely to the network layer of the OSI model. And last but not least is the network interface layer, the purpose of which is to allow your computer to access the wire, wireless or fibre optic network infrastructure and send data to other computers. The network access layer transmits data on the physical network when sending and transmits data to the internet layer when receiving. As you have probably already guessed, the network interface layer is linked closely to layer 2 and layer 1 of the OSI model. So that is a somewhat basic example of the functions and purposes of the OSI model and the TCP IP model and how they compare with one another. I hope you find this video presentation helpful with your future networking endeavours. Thank you very much for watching. Bye.